first of all, I would like you to introduce with our new co-mentor Nitish.
Hi
He'll be
everyone.
so Nitish has done few internships in machine learning and has a good background in machine learning. He has a deep knowledge and he'll be taking your doubt classes. So today what we are going to do, we are going to study NumPy, Pandas, and Matplotlib, three important libraries that that we will need throughout this course. So what I'm thinking is we are going to study NumPy on Google Colab, pandas on Kaggle, and Matplotlib on Jupyter, so that you can all get the experience of Collab and as well as Kaggle. So, how many of you think that it is right to, so that we can explore Collab and Kaggle, or you just want me to continue on Jupyter? You can just write Jupyter, or you can write explore in the message section, because I'm saying this, I think most of you would not be having GPUs in their PCs or laptops. That's why when we are going to move to neural networks, we will require high computation power. That's why I wanted you to move to Colab and Kaggle.
Guys, it is also very important because most of the machine learning competitions occur in Kaggle. It is
Yeah,
also very important.
Kaggle is quite important for a machine learning scientist or data scientist, because most of the competitions are held on Kaggle only. So if you get a hands-on experience, it will be quite useful for you guys. Let's start with our formalities first. Just I'm going to tell you about pandas and NumPy, which is written in this PPT, and then we are going to try it by our own. So let me just present. Uh, Actually, we have list in Python, but we do not use list because when we are going to do lot of multiplication, we are going to multiply two matrices. We are going to do high computation power, and we need to use NumPy, because NumPy is written in C++ and no C++ and C. And as we know that C++ and C works quite faster than Python. So we are going to use NumPy, and NumPy provides basic functions that we need. For example, sum, max, min, array, multi-dimension array that we are going to see. Basic functions in NumPy, we can generate random number with some NumPys. We can do slicing as we have done in list. All those basic functionalities available in NumPy, as well as it is quite compute intensive. So we can do more intensive computation with NumPy. And the other library is Python. Other library is Pandas. We use Pandas for data visualization to study data. In Pandas, we create data frames of our data. Actually, in Pandas, we have you must have heard about file types, extensions. I would say, for example, a doc file have .doc extension. So in here we are going to uh, uh, during machine learning course, we are going to deal with CSV file,
CSV.
.tsv files, CSV, .tsv, as well as with images and text. Uh, we can also deal with sound. We can also do sound classification. So all these things we are going to deal, few of the things we are going to deal with pandas, because pandas gives us a very good visualization of our data. It does quite a lot of things for us. that we otherwise we should have done we should have to do that manually. When we are going to see, then you are going to visualize how pandas is more important. So let's move to our next slide. Actually, it's a theoretical part. It might be boring, but it is of at most 15 minutes. Then we are going to see hands-on implementation of all these things. So next slide. Next slide is NumPy. NumPy is a code library for scientific computation in Python that I have already told you. It is high performance in multi-dimensional arrays that we are going to do. We are going to deal with matrices. We are going to deal with n-dimension arrays. N-dimension, not single dimension, but n-dimension arrays. So it is quite useful for us, and we are today going to work on it. It is the first step of learning machine learning. So basically, we need a few libraries, for example, NumPy, Pandas, scikit-learn, Matplotlib to do our basic functionalities in machine learning. NumPy arrays, grid-like values that we are going to see during the course. These functions we are going to see, for example, np.array. It also have, we can add two arrays. We can create a matrix of zeros, ones, identity matrix, and all these things we are going to do today. We can also create random numbers. We are also going to deal with random numbers. And all this stuff we are going to see today. All this stuff. We can also sort using NumPy and all these things. Now when we move to pandas, pandas actually gives us data frame of our data. So using pandas we can take CSV file, TSV file, any format file we can import in Python and work on it. So we are also going to see how pandas is useful to us. Pandas data frames are like this. Values, for example, they are like this. We are going to see pandas data frame when we are going to work on it. This is just I don't think this is necessary for us. So let's move to Kaggle. Collab, sorry. Let's see. First we are going to do a NumPy on Collab. So for opening Collab, you just need to type Collab. Search Collab in your Google, and the first link will be of Google Collab. On opening the file, you should just click on New Notebook. Down there, you need to click on New Notebook, and then your new notebook will be open. So first of all, let me give you a brief description about Collab. Here it means that we are connected to a server or not. We are connected to Collab server or not. If I'm going to click here, then it will connect me to a Collab server where I'm going to pass on my Python code, and the Collab server will do computation for me and will return my data back, computed data back. uh, mm, it is also an important area where we are going to explore in Collab. Here we store our CSV files or data files. This section contains our snippet. This section contains snippet area where it has code, already written code, and we can directly import. Snippet area. And this folder, small folder here, it is our workplace where all our data files are stored, and we import our files which are stored here. So it is our workplace. It is an important area, and we are also going to see, it is quite similar to Jupyter. It is almost similar to Jupyter. Let me tell you more things. You can also run your things on GPU. For example, if I go to change runtime type, you are just going to see that none means that you are going to run on CPU, central processing unit. When you will change it to GPU, then you are going to run graphical processing unit. It is going to process your compute things quite faster, more faster. It also provides TPU that we are going to explore when we are going to move to neural networks. So I'm setting my run environment to GPU. Uh, cool. Now let me first connect my notebook to the server. So I'm just going to press connect. My notebook is initializing. Notebook is connected to server. So you can guys see that I am having 12 GB of RAM, 12 GB of GPU RAM, and 31.42 GB of 68 GB of RDX that Collab has allotted me. And you can see when you click on this small folder, you will see here is the area where we are going to store our file when we are going to work in future projects. You can also import your Google Drive files directly to Collab. And if you click on upload, then you can upload your normal PC files. Here also we need to we can run any cell using shift enter or control enter. If we wanted to create a text field, then we are simply going to press text and it is going to generate us a text field like this. We can also delete our field here. So let's begin our coding section here. I need to enter hash numpys. Cool. And I'm going to upload this collab notebook to my GitHub account also, from where you can see your code. As we have not imported any of the libraries still yet, so I'm going to how we can import any library in Python. Just we have to write import. For importing, I should also tell you something about other languages also. For example, in C++, you always write hash include, and then you specify the header file. Just like that, in Python, we write import as we write in Java to import any of the libraries that we want to use. So we are just going to import NumPy, import NumPy as NP. So what this line means? This line means that we are importing NumPy with a nickname of NP. If we are going to use the functions of NumPy, we don't have to write NumPy as full. We are just only going to call it using its nickname, that is NP. Cool. NumPy, we have imported NumPy. And now let's make our first array in NumPy. So for making an array in NumPy, for example, a equal to np, that is the nickname of my NumPy, and I'm going to call array. You know, you have seen that Collab is quite good. It is already showing you the recommendation, the functions that you are going to use. So it's quite good to migrate from Jupyter to Collab. So it's showing me np.array, and here I'm going to pass a list, the list which I wanted to convert to NumPy. For example, I had to pass a list so that I can just write list range that we have done yesterday, range of 10. It says that I am going to convert a list from 0 to 9 to NumPy array. So let me run it. So let me display A. See, see, it is an array. Earlier we were getting list, but it is an array which is containing values from 0 to 9. Let me also check the type of A. I will write type A. See, it is quite important for you to know that it's a NumPy ND array, where ND means n-dimensional array. We can create n-dimensional arrays, ND arrays. So this is clear. We have checked the type of the NumPy array. For example, let's just try out few of the stuffs. For example, if I wanted to add, for example, in list, if I wanted to add 5 to every element, I was looping over it. But here I did not need to do that. I'm just going to say I plus, oh, a plus 5, a plus 5, and it is going to increment every element with my value. Similarly, if I wanted to decrement value, I will just write a minus 1, 1 or 10, anything you would like. So it is going to decrement my value, decrement each of my values. Cool. Nextly, I would like you to, you can also store these values in another array, array. For example, you can say b equal to a plus 5. So my b is going to store the value of a plus 5. I can also print out b. You can also store c equal to a minus 10, and I can also display c. As Jupyter displays last line, it also displays the content which is there in last line. So there is no need to write print statement. Cool, we have done this. Now let's move to, we have studied plus minus. We can also do multiply and divide. For example, a multiply 5, it is going to display me the value of a multiplied by 5. Cool. I can also check a divide by 5. Cool, it is giving me all the values that I need. You can also increase it to power. For example, every element has been incremented to a power of 2. So I think most of you have guessed. See how fast we are doing things. We are just doing smart work, not the hard work. We migrated from C and Java to Python because we wanted to do smart work, not the hard work. So we are just writing one line of code, and it is doing our all the tasks. So I think most of you might be now getting the things that why we are using NumPy rather than list, normal list. So next, what we are going to do, we have seen the majority of the task. Now let me just mark it down. Um, Not code, I need a text area. Uh, Array operations. So in array operation, what we are going to see, we have already created, let me get my pen. We have created an array of B. We have already created an array of B and an array of C, and we have an array of A also. Cool. So we are going to do stuffs with these arrays. So let me, we can also add tool, when we were adding two list, it was not actually adding, it was appending those two lists. it is taking the list one, and then it was appending the elements of list two after that. But in NumPy we just add the elements of both the list if the shape of the list is same. Before that, let me also give you a hint about the shape function. We also have a function called shape. So that, for example, if I'm going to write c dot shape, it is an attribute. So what it is showing me, it is showing me a tuple which contains a value 10, and it does not contain a value here, which means that it is a vector. Vector. It is a vector which contains 10 elements. It is not a 1D array, it is a vector. Elements. It contains 10 elements. So we can also change the vector to our to 1D array if we wish. So we can also change it to 1D array. For changing it to 1D array, we need not to do any things by ourselves. Uh, Let me insert a. So we are going to do, we are going to just write c equal to c dot reshape, and for example, it is already showing that it has arguments shape comma order. So we need to specify a shape in tuple. So what we are going to see, we are going to just write -1, which means here -1 means that we that it should not change the number of rows. It should take the number of rows which were already there, and it should change my columns to 1. So after that, if I'm going to just write c dot shape, what it has done, it has just changed from here to here, from here to here. It has just kept the number of rows to be equal, but it has added one column to it. It has modified vector to 1D array. Vector to a 1D array. I can also modify my this array to 2D array. For example, it is containing 10 elements, 10 rows and 1 column. So I can also modify it to 2D array. For example, 5 rows and 2 columns. I can also do that if I wish, with the help of reshape function according to my need. I'm going to use this function according to my need. Okay, I have told you reshape, I have told you shape. Now let's do few of the NP array operations. For example, we need to add two NP arrays. We can do that. I can write just a plus b, and it is going to add both the arrays. For example, my array was, let me print both the arrays, print a and print. Cool. You are getting that these two arrays are added element wise. For example, where is my, if I am having element 1, 2, 3 in my one array, in second array I am having 4, 5 and 6. So my new array will become 5, 7 and 9. all these elements will be added. So similarly, we can subtract and multiply also. Actually, I just need to tell you something. If the shape of both the array will not be same, then it will not perform operation. So the shape of both of the arrays should be same. And similarly, I can do a minus b. It is subtracting both my arrays. I can do a multiply b. It is multiplying individual elements. What we have seen in addition, similar things are happening here also. And I can say a divided by b. See, I'm getting all the operation done quite fast and seamlessly. So let me also tell you about the power. I can also increase a raised to power b. See, all elements are incremented to a power. A plus c का result क्या होगा? Okay, okay, okay. Uh, a plus c. It is going to perform vector addition. Let me just tell you. Uh, A is our vector and C is our 1D array. Cool. So what it is doing is it is taking the elements of C and multiplying it by taking all the elements of C and multiplying it by individual elements of A. For example, let me just print out both A and C so that it can be quite clear for you. So what it's doing is it is taking the uh, are you getting? It is our vectors. It is our 1D array and it is our vector. So what we are doing, we are taking 0 and adding all the elements. Let me draw it by O. We are just picking 0 from A and adding it to all the elements of C. Then we are picking 1 and adding it to all the elements of C. And then we are picking 2 and adding it to all the elements of C. Are you getting it? Sir, can we reshape the array of our own? Like if we have 10 elements in array, can I reshape it to um, you can't reshape it to 4 cross 4, because if I am having 10 elements in my array, it is going to be 10 comma 1, whereas 4 cross 4 will contain 16 elements. Are you getting it? Number of elements are not same. You can reshape it only when your starting shape and ending shape has the same number of elements. Are you getting it? We can also create a 2D array with NumPy. It is also quite easy to create 2D array as we created our 1D array. For example, what we are creating a D with, we want to create D, a 2D array. We just simply write np dot array. And here we are going to pass a list which is containing a list. So it has created me a 2D array. As you can see, my first row contains 1, 2, 3, and my second row contains 4, 5, 6. Cool. So we can also create a multiple dimension array as we like. Let's move on to our next topic, which is we need to explore few of the functions of NumPy. So let me just uh, if I wanted to create a matrix of zeros, then what I will simply write, I will write A equal to NP, the nickname of my NumPy, NP dot zeros. See, see, it is giving me the recommendation. So collab is quite good, quite good. If you are going to move, it is also going to show you what arguments the function is taking. So I need to just pass shape and type, D type. We are going to discuss about it in quite a detail. D type that you have seen. D type, we are going to discuss about it. So NP, I need to pass shape. First, let me give shape. I need a zero matrix of, for example, 3 comma 4. Cool. And I'm also going to print A. See, it has given me a zero matrix, but if we look closely, that it is a floating value. Zero dot. It has written zero dot. Are you getting it? If I need a zero matrix containing only integers, so I can specify type also. D type equal to int. I think I is capital here. Int. Oh, yeah, I is small. Now what you are seeing is that it has returned me a matrix of zero containing only integers. Is it clear? If np dot zero is clear, just write zero. We can create it of any dimension that we want. You can also create, it is 2D, you can also create a 3D matrix. Let me see how many of you can visualize it. uh, np dot zeros. uh, Let me specify 3 comma 3 comma 3. Okay, so let me also print it E, and here, okay, let me run it here. uh, Print E. I'm going to explain it in depth what is going on here. So what we are creating is we are creating a 3D matrix which is containing 3 row, 3 column, and a depth of 3, or you can say 3 dimension. So one of my dimension is this, my second dimension is this, my third dimension is this. uh, uh, I have used the print function so that it could be a lot clear. Here it is just a few of the starting brackets and ending brackets. Just I wanted to avoid that.
तो NPRA can जिसमें जो आप D type लिख रहे हैं,
Yeah, yeah, yeah.
D type as character or string.
Cool. So as we have studied that we can make a list of string. Cool. So we can also create an NP array of string. Let me just create. Uh, Let me write str. Oh, str is a function, inbuilt function. We can't use that. S equal to np dot array. array, and we are just going to pass a list. For example, I'm just going to write your commenter name, Anmol and Nitish. Cool. And you can also print it out. Also, I can print here. It is also telling that it is an array, not a list. We have studied np dot zeros. Now let's move to another function which is we just wanted to create a matrix of 1 containing all 1. So what I'm going to do is I'm going to just write a equal to np dot similar. We have a function of ones also, np dot ones, and we are just going to pass shape and d type. D type we have already discussed. So I'm going to pass a shape of 4 comma 3. I've just passed a set object. I need to pass a tuple. Cool. So it has created me a grid of all ones. I can print it out here. See, it is containing all the ones there. Cool. Are you getting? You can also, if you want it to be of type int, you can also change d type. D type just means data type. You can just write int here. Cool. It is working really fine. After this, we also have a function of I. You must have read in your 11th or 12th class about a function identity matrix. For example, where we, for example, if I'm having a matrix of 3 cross 3, so all my diagonal elements will be 1. Are you getting it? All my diagonal, it is identity matrix. We usually represent it by I. Mostly in 11, 12th, I'm just forgetting in which class I am. So it is identity matrix. NumPy provides us a function to also draw an identity matrix. I can just write a equal to np dot I identity matrix, and I'm just going to provide the shape. So, let me just tell you something here. It is only asking me only one argument, that is n. Can anyone tell me why it is asking n? Anyone? It is quite simple. Quite simple. Quite simple. It is not asking two arguments as ones and zeros were asking. It is only asking me a single argument, that is n. That what dimension you wanted to make. Identity matrix will be n cross n. Yeah, you are clear. Utsav, you are quite clear with the concept, and you are quite close to the answer. Yeah, it is a square matrix. Yeah, Utsav, yeah. As we all know that identity matrix is a square matrix, so we just only need to give one argument to it. So it will make rows and columns to be 4. Rows and columns to be 4. Similarly, it also have more functions. If you wanted to explore, for example, d type, where it is currently giving us float. By default, it is float. You can also explore other option. For example, m, which is optional. You can also specify number of columns that you want to get. K diagonal index. No, I don't think it is. If you are preferring to explore, you can explore about the upper diagonal, lower diagonal element that we have seen in class 12th. So I think it's now time for me to ask a question. So my question is quite simple. Let me first draw it. I just need a matrix which is containing 4 rows and 3 columns, and all the element of the matrix should be 5. Should be 5. All the elements should be 5. Anyone? Can anyone tell me how I can do that? All the elements should be 5.
Sir, firstly we can call the ones matrix, then multiply that with 5.
Multiply that with 5. Yeah, you are right. Yeah, you are right. Absolutely right. Can anyone tell me, without using ones matrix, can we make it with the help of zeros matrix?
Sir, we can add 5, 0 plus
Yeah,
5.
yeah, you are right. We can use both the metrics that we want. What we are going to do, le- I can create a matrix A, np dot ones of dimension 4 comma 3, and I can just say A multiply 5. See, it is currently of float type. We can also convert it of integer type from here by specifying the d type int. Cool, I'm getting the metrics. The next we are going to see study is random functions. Okay, okay. NumPy also, let me just mark it down. Oh, battery is low. Let me just connect it to the power supply. The next we are going to see random functions. So NumPy provides us with random functions. I can write np dot random dot random int. See, let me tell you about the arguments. Uh, it is having an argument of low, high, size, and d type. Low means that from where my value should start. If you are going to go down, also let me tell you how you can read the documentation. You just go to here, you just write numpy random int documentation. You just need to write this and it will show you the documentation of that function that you are currently using, so that you can just see what arguments are there and you can make the best use of it. That, for example, it is having a low value, a high value which is optional. Cool. Is having a low value, high value, and a size. It need a size, how many random values that it should generate. So I just need to pass low, that is I'm going to 1, and high that I'm going to take 10, and I need 5 random 5 comma 1. So it has given me random numbers from 1 to 10. It has given me 5 random numbers from 1 to 10. Is this clear? If I'm not going to specify that how many random numbers I need, it is just going to give me a single random number. Single random number, every time I run, I will get a new number. See, now I'm getting 3. Is it clear? If this thing is clear, you can just write random. Let me just write this in Excel. I can just this packet is necessary. Cool. So see, it is giving me 4 now, and if I wanted to get a random number of a matrix of 3 comma 4, I can get it. Cool. Cool. I think most of you are getting it. It is giving me a random integer of type int. You can also explore the D type option to create a random integer of type float. And moving on to next topic we are having is we can also do a slicing. For example, let me tell you slicing of arrays here only. For example, let me store it in some variable a. Now my a variable is having random numbers. Let me print that out. A a dot shape will give me the shape of a. Cool. If I just wanted to see values, I don't want to see the first column or first row. I don't want to see first row. I just wanted to see the values which are present below first row. So I can simply say a. It is important. Let me just tell you about them. Uh, Here I am going to pass the starting index, and here I am going to pass the ending index of row. Similarly, here I am going to pass the starting index of column. Here I am going to pass the ending index of column. Uh, so it might be clear for you if I run out the cell and show it to you. For example, if I am running this cell, I will be getting all the elements. But I need elements starting from first row. So what I'm going to do, I'm just going to write 1. I need rows starting from 1 to end and all the columns. See, I'm not getting the first row. I'm not getting it. If for example I don't need first column. For example, I need to remove the first column. I can simply write here I want my column to start from 1. See, it has removed my first column also. If I don't want to see my last column, so I need to specify the index of that. For example, this is my 0 index, first index, second index, uh, and third index. I don't want my third index. So I would just write 3, as I've already told you. Generally in Python, when we specify indexing, the starting limit is close bound and the ending limit is open bound. So it will not include the third column, third index column. So let me run it out. Cool, I'm not getting that column right now. So is it clear? Slice if next topic we are going to explore more functions. So next more functions. Let me also specify what functions we are going to explore. Let me give it a heading type. We are going to explore min function, max function, and Min, max. Just give me a sec. Let me check out what functions we are going to explore. Min, max, we are going to explore mean, variance, mean, variance, standard deviation. Standard deviation we are going to, yeah, these functions we are going to explore. So let us explore all these functions one by one. So if I just have an array, np array, np array with elements 1 1, 2D np array with elements 1 1 comma 2 2. Cool. Let me print out a. Uh, there is a syntax mistake. Okay, I have not comma comma. Cool. I'm getting a. The first row contains 1 1 and the second row contains 2 2. Cool. If I wanted to find out the minimum of a, I can just write a dot min. It is going to provide me the min. We are and also we can if I want to check out the max, I can also write a dot max. Let me change the elements to 3 and 4 so that it could be more clear. Cool. A dot min is going to give me the minimum, a dot max is going to give me the maximum, and we also have few of the NumPy functions. For example, if I am going to write np dot min, sorry, and I'm going to pass my array a. It is giving me the same answer. Cool. Now, similarly, we have a np function for max also. And now let's move to standard deviation. np dot std, standard deviation, and we need to pass a, and it is having a parameter known as axis. Guys, it is having a parameter known as axis. We are going to exploit that parameter. First we are not using axis. Next on we are going to use axis. For example, I need to find the standard deviation of a. It is giving me the standard deviation including all the elements. For example, if I write axis a, axis, in axis I am having two value, one is 0 and other is 1. If I write 0, then it is giving me two values. Let me explain it to you. I'm having an it is of 1 3 4 2. When I specify axis 0, axis 0 means it is going to give me the standard deviation row wise. So first value is the standard deviation of this row, and the second value is the standard deviation of this row. It is giving me standard deviation of row wise element. If I am going to specify axis 1, then it is going to give me the standard deviation column wise. I think this thing is clear to you all. So let me just write a standard deviation with axis 1. So it is giving me the standard deviation on axis 1. Cool. Similarly, we can variance. np dot variance. Variance, I can, let me check out the function. It is variance or np dot var. Np dot var. Reach var. It is np dot var. So I'm having a function np dot var, which is going to give me the variance of a, and axis I can choose any of the axes. Cool. Sir, random numbers, when I am executing, I am getting some number filled, not numbers filled, not changing. Lokesh, can you specify your question a bit more clearly?
Sir, like when we execute random numbers, the numbers must be changed now, sir, when we are executing.
Yeah.
But in my case, it's not changing, sir. I'm getting the same.
Yeah, cool. Let me tell you about that. Also, we have a function in NumPy that is np.seed. np.seed, actually what it takes a random state. For example, if I'm going to pass, if I am commenting it and I'm just running np.random dot random int, and I'm just passing 10, 10, 10, 10. What I'm getting is I'm getting 7, and the next time I will run is I'm getting 5. If I want my number to be same, it should not change. So I'm just going to specify np.seed, and I'm going to specify a seed value. The seed value can be of it can be any positive value. You can specify any value for seed. For example, if I specify 10, wait a minute, np has no attribute seed. np dot random dot,
रैंडम सीट आएगा, रैंडम सीट कर दो.
yeah, np dot random dot seed, sorry, np dot random dot seed, and I just need to specify a seed value. If I'm going to run it, I'm getting 4. If again I'm going to run, I will again get 4. The value of my random number will be same. It will generate same number how many times I run. For example, if I write a for loop for I in range 10, and I'm going to print it out, everything. I'm going to print out the random number that I'm generating. Control V. It will give wait a minute, it is giving me a different random number.
क्या उस सेल के लिए होता है, उस सेल के लिए.
Yeah, I got it. And I will specify a seed value of it also. See, if I have specified a seed, it will give me the same number. I don't know why it is giving me a different number.
लूप के अंदर.
Initialize it in loop.
Yeah. Actually, seed does, it gives us the same number every time. Every time I will get the same number. If I will comment this line only, then I'm going to get the different number every time I will run the random function. So guys, I think random function was our last topic of today. Wait. We have one more function. It is np.stack. If I am having a list, for example, a list of elements containing 3 values, 1, 2, 3, and I am having a B which is containing value 3, 4, 5, and I can stack both the I can create a 2D matrix out of it by placing one over another. For example, I will just write np dot stack Also, let me create it of NumPy np dot array np dot array. I can simply stack two arrays over one another. What they will do is they are just going to put array 1 over the array 2. So I just need to simply pass a comma b as an argument. So you can see my array 1 got placed over array 2. If I'm just going to reverse it, so the array 2 will come first. See, I can also change the axis. Currently it is placing row wise. I can also change this to column wise by specifying the axis parameter to 1. By default it is 0. See, my B is coming first and then my A is coming. So I think all these functions are there in NumPy that we are going to need. If there is any doubt, you can ask me right now, and we are going to have a doubt session after it, where I'm going to give you 3 problems from HackerRanker, and you are going to solve that. In this problem, we are exploring about dot and cross products. We have studied in matrix what is dot product. Dot product is simple. Dot product easily you can relate it to matrix multiplication. Matrix multiplication. It is known as dot product. When we multiply two matrices, it is known as dot product. And for vector product, you guys might have done uh, uh, computations like you have to multiply two matrix with plus, minus, plus, minus, plus, minus, plus. Here what you do, you just multiply them and subtract them. This kind of thing that you have done, this is known as vector product. So the first question was quite easy. So in this, you just need to do matrix multiplication, or in another words, you just only need to use dot product. It has given us the example how we can use dot product. It's quite simple. We just need to write numpy dot dot and just pass on both the numpy arrays that we are having. So I just wanted to ask how many of you were able to take input. Those who were able to take input, just write input. So let's see. If we go here, it is saying that it is giving input n, and then n line separated and integer values will be given to us. So what I'm going to do is I will define a variable n in which I'm going to take an input. By default, the input comes in string, so we need to typecast it to integer. So I'm taking the input. Now I need to take a matrix. I'm just taking an empty list A, and now I need to take n rows. For taking n rows, I am just going to write a for loop for I in range n. Then what I'm going to do is I'm just going to take the input of the line in a temporary variable known as temp. I will take full line input of full line. What I'm going to do is I'm going to strip it and split it. And after that it is going to give me a list, as we have seen in previous class. And what it has said that we just only need to take n elements. So what I'm going to do is I'm going to do a slicing where I'm going to take only n elements starting from 0 to n. By chance the user uh, uh, sometimes the user might try to give more than an input, so I'm just writing it so that the input should be from 0 to n. Now I need to convert all the elements of temp to integer type. So what I am going to do is I'm just going to do a list comprehension where I'm going to do int I for I in temp. It is going to pick one element from temp and going to convert it to integer. And after that, I'm just going to do a dot append temp. Is this clear? So what I'm doing is I'm creating an empty list A. A is my empty list. And what I'm doing is I'm here getting the input that how many rows and columns will be there. uh, how many rows and columns will be there. Rows and columns. Okay. Cool. Now what this line is going to do, what this line is doing, for example, the user is giving me 1 space 2 space 3. For example, I'm just assuming that the user is giving me this in string. We know by default we take string. So what I'm doing is I am stripping the area by default if spaces are present in front or after the string. So dot strip is removing the spaces present, and dot split is what dot split is doing. Just wait a sec, let me change the color. Uh, what dot split is doing, dot split is changing it into a list where one is my one element of type string and two will be my another element of type string. Exactly. Two will be my another element of type string and three will be my another element of type string. So what I'm doing, I need to take uh, only n columns. So what I'm doing is I'm just slicing it out. And slicing it out, I'm just taking only starting n elements. So what this is going to do, this is going to remove extra element if they are present, extra element if they are present. If they are not present, then it is going to do nothing. After that, what I'm doing is this line must be clear. It is list comprehension that we have studied earlier. In this, we have to read from last. But what I'm doing is for I in temp, it is going to pick one 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 value at a time. First, it is going to pick one, and then it is going to convert it to integer. Then it is going to pick two, and then it is going to convert it to integer. Are you getting it, Diksha? Dishika, are you waiting? Yeah, cool. And lastly, what I'm doing is I'm just adding my this temp to there. For example, I'm adding 1, comma 2. And similarly, I am also going to add my second list to it. For example, if it is 3, comma 4, it is going to be added as this process is repeated. Similarly I'm going to take the input for B also. So what I'm doing is I'm going to copy all this thing and I'm going to paste it out. uh, uh, I will take a new list with name B. Cool. I've created a new list and I will append this in B. Now I just only need to return the dot product of both. So I will just write np dot dot, and I'm just going to pass a comma b. Cool, cool, cool. So let me just run it out. No response on std out. Expected output, no response. Okay, we need to just print. Sorry, we need to print. Uh, See, I think we are getting the right answer, so let me submit it. Yeah. So let's see our next question. Next question is this was next question, hacker anchor. I think mean variance. Okay. Problem is the mean tool computes the arithmetic mean of a specified along axis. This we have seen in class. You can just compute the mean to any axis. If you are going to specify the axis, it is going to calculate over there. If you are not going to specify the axis, it is going to calculate the mean of full matrix. So and similarly for variance also, and standard deviation also. So what is our task? Our task is you are given a 2D array of size n cross m. Your task is to find the mean axis, mean along axis 1, the variance along axis 0, and standard deviation along axis none. Okay. So guys, let's do that. So what we are doing is we are taking a variable n in which we are going to take input. As our input contains two variables, so it will be of string type. So we are going to strip it and also split. Now we have taken the input, but it is of type int. So we need to convert it to integer type. For that, we are just going to do for I in input, and I'm just going to convert it to type int. Cool. Is this clear, guys? This simple dictionary comprehension or list comprehension that I'm using right now. So let me comment it out. Here my n0 will be defining rows, and n1 will be defining columns. It is going to define rows, and n1 will be defining my columns. Cool. The next thing is we need to input a matrix of row comma column. So similarly, as we have done earlier, what we are going to do, we are going to take an empty list, and we are just going to write a for I in range that is n0. We are going to take this amount of rows, and also we are similarly we are going to define a temp variable in which we are going to take input dot strip dot split. Cool. And I will make sure that it only contains m columns, so I will specify n1. It should not contain more than that column, so I'm slicing also. Now I will just change it to type of int. For I int temp, cool. And I will do a dot append temp. What this line is doing, uh, they are providing me two values of type string. So what I'm doing is I am just stripping, removing this area and this area if it is there, and another, and I'm splitting it. So what it is converting, it is converting me it into this 2 and 2. After that, what I'm doing is I'm just converting this to integer. That is, I'm converting it to 2, 2. So we know in list the index start from 0, so it is 0 index and it is first index. So it is specifying rows and it is specifying columns. Are you getting it? Then it's simple. What we need to do is we just need to print the things. Print, let me take NumPy as NP. What we need to print is task, task, task. We have 1, 0 and none. Okay. Mean along 1, variance along 0 and standard deviation along none. So I will just write np.mean, np.mean, and what I'm going to do is I'm going to pass a along axis equal to 1. Similarly, I'll copy the code, and what I'm going to do is I'm going to pass, instead of mean, the variance along axis 0, and I'm going to print the standard deviation. Standard deviation. Let me just run the code. Yeah, there is no error right now, so let me just run it out. Indentation error. Oh, okay, line 2. Cool. There was an indentation error. These all things are intended, so Python was unable to see which thing is which where. So I think it is correct now. So let me just run it again. Input, output, expected, where it is expected. Yeah, I think we are getting the same, exactly same output. So let me try to submit it also. Actually, it's not passing. Let me check where it is. We are 1.5, 3.5, 1, 1, 1 tiga. Okay. So I think most of you were not able to pass this. This is because we need to print in exactly the same pattern as hacker anchor wants us. So what we are going to do, we are going to see one more function, which is np dot set position. Np dot set underscore position, if I am correct. Yeah, here we need to just specify the legacy. Not Matplotlib, it's NumPy. Spine, Matplotlib, NumPy. Yeah, it is there in NumPy. There is a function called set position, which is used to specify whether how we wanted to just output the code, how we wanted to output our syntax or anything. So that's the error. Otherwise, we are all doing it logically correct. Just there is a function. Uh, Let me just guess it out. It's numpy dot set print option. Maybe it is. Yeah, it is set print options. So here we need to specify legacy. There is a argument that we need to specify. It is here legacy, and we need to specify the legacy 1.13. And if we are going to specify, so what we are going to do, we are going to np dot set uh, print option, uh, print sorry print print options, and we are just going to specify legacy equal to 1.13. Yeah, cool. So let me just submit it again. I think it is clearing now. So it is just a trick that hacker ranker wants us to specify our input. There is no logic in this. It's just I think the hacker ranker should improve on it. Uh, we need to transpose and flatten the matrix. So the syntax is quite clear: np.transpose and np.flatten. Cool. So we need simple output containing rows and column. So let me just write the code fast. It is quite similar to the problems that we have done back. Cool, we have taken the input. Now we need to create an empty list for I in range of n0. We are running it out. We are creating a temp variable for that, in which we are going to take input. Input we have taken, we are going to strip it, and we are going to split it, and also we are going to slice it so that we just remove the extra numbers or strings that we have. Now we are going to convert it into int. It is simple. We are just going to use list comprehension for I in, and then we are going to append a dot append temp. Cool. Our task is to print, flatten, and transpose and flatten. Cool. So we are going to simply print uh, np dot transpose of a print a dot flatten. Cool, guys. So let me just try to run the code. Error file module a dot flatten list has no object. Okay, I'm getting it. I need to convert list to NumPy array. So what I'm going to do, I'm np dot array of a. Cool. Yeah, it is clearing. So all my test cases will be got test case have got clear. We are going to study pandas in Kaggle. So for studying pandas, we are having our data. We are going to see a data set. We are just going to see a data set which is movie metadata, and we are going to see it on Kaggle. So what we are going to do, we are just going to write Kaggle movie metadata. Movie metadata. Kaggle movie metadata. Okay, the first link you are going to see is the data on which we are going to perform. Let's just explore the data. It is saying the file is not having a description, so we are going to explore it by ourselves. For creating a new notebook as we have created in Collab, just we need to uh, uh, press new notebook, and then we have to press create. Uh, okay, I can repeat the Kaggle part. Wait a sec. Uh, so what we have done is I just googled Kaggle movie metadata. So on the first link I clicked, I just got to Kaggle and then I just pressed new notebook. Is it same? Let me just check it out. The data is specifying of 90 MB. It is not. It is. Just write Kaggle movie metadata and this link. I'm just pasting this link in the chat also. If you are not able to this link. Wait a minute to everyone. I just this link. You just need to go to this link. Then you just need to press new notebook and then just click on create. As we have changed the runtime in Collab, we can also change the runtime here also. It is known as accelerator. So just go there and press GPU. If you just want to do it on GPU. And it is going to turn on your GPU. And it is going to start your notebook with a GPU. Cool, the notebook has been started. So what I'm going to do is I also need to tell you a few of the things. The data section where our data is present here, it is present in movie metadata. It is a CSV file, as you can see, .csv. Let me just run this first block. In this first block, I have imported NumPy and pandas. Cool, and we are going to work on pandas. So Kaggle has given me the location where my data is present. So what I'm going to do is I'm just going to import my data to the Kaggle, which is really simple. I'm defining a variable df, which is equal to pd dot read underscore. Let me see what Kaggle suggests. Because I'm going to show you, you can just read any file, any format file that you want. Pandas provides you a basic, let me tab. Otherwise, we are just going, yeah, it is showing. We are just importing CSV, so we will click on CSV. Otherwise, you can open Excel, Feather, FWF, HTML, JSON, and anything which you like. You can also open the databases which you like, tables, S data that you like to open. So we are going to open CSV. So we will like CSV. And in strings, we are going to define the path where the data is present. So Kaggle has given us the path. If you are running on your local PC, then you can specify the path. For example, uh, the path that you have. I've run this code and my data is loaded. For example, in normal PC, you guys have path like user dash OneDrive slash username slash. You just need to provide the path where this data is present, CSV file is present. Pandas also provide us with basic functions like we can check what is there in our file. We just need to write df dot head. So it is giving us the top five rows which are there. It's giving us top five rows. And we are having 28 columns. Cool. Uh, if I wanted to see 10 rows, I can just pass in here argument as 10. By default, the argument is 5. So it is going to give me 10 rows from 0 to 9. And similarly, if I am having a head function, the data frame also gives me a tail function, df.tail. By default, I can see the last 5 rows. If I want to see last 9 rows, I can just simply type 9 and it is going to show me 9 rows, last 9 rows. Cool. I think this might be really easy. And one more thing I should tell you that this is known as header. The top bold thing that you are seeing, header, and they are also known as column names. For example, the first column name is color, the second column name is director name, the third column name is num underscore critic underscore 4 underscore reviews, and so on. So we have seen this and we can see more of it. We can, as we have seen in NumPy, we can also see the shape. We just need to write df dot shape. So what it is showing, it is containing 5043 rows and 28 columns. Cool.
Sir, actually, I'm not be able to add the data on the Kaggle. So can you please repeat it?
You just need to run the first block. It is going to give you output. You just only need to copy paste that here in form of a string.
Sir, it is not showing.
You need to run the first cell. Have you opened the link that I have given to you?
Yes, yes, sir.
अरे
uh,
अपलोड नहीं होगा डाटा, अपलोड कर दे डाटा, अपलोड डाटा करना पड़ेगा।
एक मिनट रुक जा
ड-
yeah,
तूने
check
पहले
is it
अपलोड,
present in movie metadata. Check out on the right side. Is there present any movie metadata.csv? Dikshant?
Sir, it's done. Thank you.
Yeah, cool, cool, cool. I think we are clear with head and tail and shape. Uh, now we are going to explore some of the cool features of data frame like df dot info. What it is giving? It is giving me info of every column. It is saying first column it has 5000 rows and no null values. This no null, we are going to see that in our next class when we are going to see study pipeline. And it is giving us the information of all the columns that we have right now. We have one more function of data frame, that is df.describe. What it does is, I need to explain it in a bit detail. Uh, where is my pen? So the first gives us the count, how many things are present in that column. It is only going to show columns which are of integer type, integer or float type. It is not going to show me the columns which are of string type. As above we have seen which columns are of float and int type. It is describe is going to show me only that column. So first thing gives me the count. The second thing gives me the mean value that every column contains. And the third row gives me the standard deviation that every column contains. And the fourth gives the mean. These four things are important: 25%, 55%, 75%, and max. So let me just draw something for you and we are going to study them. What are they? Uh, um, Most of you have been studied in college a function like that. Most of you have studied. So here we have mean. This function is z equal to x minus mean that we represent as mu divided by standard deviation. Are you getting it? This function is this. So what 25% says that 50. For example, if I'm going to see for a row critical critics for reviews, it is saying that 50. Here I am having a point dot 50 till 50. I'm getting 50% of the things. Cool.
Hello.
And the next thing is
Hello.
uh, for 25 for 50 sorry guys, it is 25%.
Hello.
Yeah, you are audible.
I
uh,
wanted to know how you added the path. I am unable to do so.
I will surely tell you, but let me just complete it. I'm in
Okay.
the middle of topic, and if I'm going to, then you might be unable to visualize this. So 50% means that I'm having a value of 110. So we have seen that 50% of data comes left side and 50% of the data lies right side. So here my uh, value will be 110. Oh, sorry, I have written it wrongly. It is 50, right? So it is 110 and it is also my mean. So this whole area contains my 50% data. Cool. The next thing I am having is 1.95. 1.95 is here. So 195 I am going to place it here. So what this is showing that my all the data, 75% of the data lies in this region, to the left of it, to the left of it. And for max data, our value is 8135, which is going to be here approx 8135, 813, sorry, 813. Is this clear? If this function is clear, just write clear, because it is important to visualize what the last four things are giving us. Yeah, cool. Let me clear it out. To add path, you just need to just run first cell of this notebook and just copy this path. Just copy this part and add it here as a string. Pass this function's argument as a string, and everything will work for you. So guys, we have seen this. We can also see few of the more things. For example, how one column is related to another column. We can also see that is df dot correlation. We can correlate one column with another column. This will correlate my column with another column. For example, the diagonal will always contain 1, because if I correlate x with x, it will be always x equal to 1 into x. So their correlation will be always 1. For example, duration is correlated with number of critic for views is 0.5. That means if I increase value of number of critics by 1, the value of duration is increasing by 0.25. Are you getting it? If you are getting what the correlation is saying, for example, I need to draw. For example, my x is correlated with y. The correlation can be of any type. If my y increases, then my x can also increase. So they are, the values of both are increasing. The next situation can be the value of my y is increasing and the value of my x can decrease. One more scenario will be there. Value of my x is increasing, and to balance that out, value of my y is decreasing. Another case is if they are not correlated, the value of x will not change if we increase or decrease value of y. For example, I am picking this column. So what it is saying that if I increase number of critic reviews, obviously my value for critic reviews will increase. Cool. The another thing, duration is related to critic reviews by 0.25. That is, if my critic review value I will increase by 1, then my duration value will increase by 0.25. Another thing is that director Facebook likes. If my critic value is increased by 1, then this my value will be increased by 0.18. So similarly, actor 3 Facebook likes. If my number of critic reviews is increasing by 1, these are increasing by 0.27. So similarly, the case for this, for example, here, if my number of critic reviews are increasing, then the face number in poster is decreasing by a value of 0.03. So it is negatively correlated with my this column. So so it is giving us the correlation between every column present in the data set. So are you getting it? What else we can see? We have done describe, we have done correlation. Okay. If I wanted to see a specific column, I just need to write df and then specify its name. For example, let me take a string column which is containing a string, so that I will be able to use it for the further task also. Uh, for example, director name. Cool. I'm copying this column and I'm just pasting here. So I can view a specific column with the help of like this, or I can just df dot and then paste column name. Then also I'm going to see the column, and if I'm going to see df dot get and specify column name. I think here I need to specify string value. Then also I'm going to these three, with the help of these three method, we can get the column names. Mostly I would generally prefer to use this or this. This is not commonly used. So we got the column name. Now, for example, if I need to find the unique value in this column, so what I'm going to do is I'm going to do df of that column, and I'm just going to write unique. Uh, we have a function unique. It is going to display me the unique values. For example, we are having directors like James Cameron, Gore, Vervinsky, Sam Mendes. These directors we are having. Cool. Now we can also see what unique values my data frame also contains. We can also see df dot n unique. It is function which is called n unique. So it is saying that my color has two values. Color has two unique values. Director names have 2398 unique values, and similarly duration has 191 unique values. Similarly, if this is clear, just write clear. If this is clear, can you explain describe? Okay, okay. Describe, just describe. Let me just open it. It is tail. Where is describe? This is describe. It just gives the count of number of things that are present in that column, the mean value that is present in that column, the standard deviation of that column, the minimum number that is present in this column, the maximum number that is present in this column. And this I have explained. If you are having any doubt, you can contact any of the TA. Correlation I have explained, and it is going to be a bit more clear if we are going to plot heat maps. So we have seen n unique and unique. We have seen n unique and unique. Cool. These things we have seen. Let me check out what other functions I need to tell you. I've told you tail. Okay. One of the main thing that, let us also see type of data, type of df. So it is saying me it is a type of pandas.code data frame. So it is saying it is a type of data frame. So also we can convert data frame into NumPy values with the help of an attribute. Let me convert it to NumPy values. We can convert data frame to NumPy values with the help of that. I'm taking a value a which is a NumPy array, and I'm just going to write df dot values. So it will convert my data frame to NumPy. I can check out with the help of type function, type of a. So it is my data frame, and I can convert my NumPy array back to data frame with the help of function df dot pd dot data frame and pass a NumPy array. So what it does is it creates, it changes my NumPy array back to data frame, and I can check its type by typing type of B. Cool. It is. I've converted it to NumPy and back to data frame. I think we generally have this much of function, and our pandas is clear. We are also going to plot these things when we are going. We will in next class only. We are going to plot these things also.
Sir, just like CSV file, can we include other files like HTML,
Yeah.
XML?
I explained it. When you write pd.read underscore, and I have shown you that you can include CSV, Excel, feather, HTML, JSON, and all types of file.
Sir, if I would like to take it from my local repository, then
Yes,
just I would like to paste it like just the path is enough, sir.
Yeah.
yes, you can upload from upload data. There will be feature in Kaggle file in file in
Okay, sir.
You just need to upload data. You just need to go to file and then upload. Then
Okay, sir. Okay.
your data will come here, and then you can just import it.
plus add or upload data.
Sir, if I insert an image here, then could I perform that the same functions what you specified on it, sir?
Actually, speaking of image, we are going to talk about images on our class 4. So it will get a bit confusing if I will explain it to
Well, generally, we don't use pandas for images. Just
you.
understand this only.
Yes.
Till now.
We are going to work with image, no problem, but on 4th class. So now let's move to our next topic, which is uh, what say. Let me just save this link so that I can share it with you. Uh, just save it. The next thing we are going to see a few amazing things. I think you might be bored by now. Now we are going to see few of the amazing things. We are going to plot maps, and we are going to do much more of the good stuff. So for that, I'm just going to use Jupyter. Now I have told you how to use Colab, how to use Kaggle. Now let's see Jupyter also. So let me just open my Jupyter. I'm just closing Kaggle. Jupyter notebook. My Jupyter notebook has started, and let me go to the folder on which we are working on. It's VAC 18ML day 2. Cool. Now we are going to create a Python 3 notebook. And I'm just going to name it Matplotlib. Matplotlib. Cool. So for importing Matplotlib, we just simply we imported pandas, we imported NumPy in the same manner. We are going to import Matplotlib. Import Matplotlib dot pyplot as plt. So cool. Matplotlib has been imported, and we are going to require NumPy array. So I'm going to import NumPy also. Oh, sorry, I just made a typo. Cool. Both my Matplotlib and NumPy are imported. So first we are going to see. So first, let me create an array of A equal to np dot. Let me tell you one thing. If you don't know what the function is having definition or arguments, you just need to type question mark and press enter. It is going to show you what arguments the function is taking. Array, we can create an array of x with the help of range function. List of range of n, and I'm also going to print a. Cool. I can also create an array with NumPy only with the help of a function np dot arrange. I think a range. It also needs three things. Start. Let me just specify you. Yeah, it also needs start, stop, and step type. So we can also create a NumPy array directly with a function of a range. So cool. Let me just make starting from 0 and I need to go to 10. Cool. Let me also print it out. Cool. My both arrays are complete. Now what I'm going to do is, let me just mark it down. First, we are going to do a scatter plot. Scatter plot is just like plotting points. So what I'm going to do is, I'm going to do a plt dot scatter, and here I'm going to pass my x and y. My x is a and y is b. Cool. And I just write plt dot show to show my plot. Cool. So see, 0 comma 0 has been plotted, 1 comma 1 has been plotted, 2 comma 2 has been plotted. So my straight line has been plotted. Also we can see few variations also. If I would have taken np dot random dot rand int to I think 20, maybe go cool, with a shape of 10 comma 1. Value error. What is value error? Low is greater than high. Okay. So let me generate 20 values. So my low is 20, 0, and I need 10 values. So I will write 10 comma 1. Cool, I got 10 values. Now I can just plot them also. See, with scatter plot, I'm just plotting all the points. Few features of scatter plot are, for example, I just need to show the grid also. So I would just write plt dot grid. It is going to show me the grid. So if I change back it to previous version, let me comment it out, be equal to np dot arrange 0 to 10. So let's run it. So what we are seeing, we are getting a grid. So we can see that our points are plotted nicely. Now we just wanted to provide the labels. So we can also provide with the help of plt dot x label, and we can say it is a. Cool. We can also provide y label, plt dot y label, and we can just write y. B. Sorry. So see, A, B are appearing there. As you can see B and you can see A. And also let me, I think scatter plot is this. Now let's move on to the next plot that we are going to see. We are going to plot lines. Mark down, let's plot lines. What we are going to, we are just going to do plt dot plot function which is used to plot lines, and we are going to pass A comma B, and we are just going to write plt dot show. We should write always plt dot show at the end. We should always. So it has given me a line, straight line, without scatter. I can draw multiple lines here. I can just draw plt dot uh, plot. Let me plot a line for square also. See, I'm getting 2. Actually, my x should be same and my y value should be different. That is why the parabola is going in some another direction. Now it is clear. So my this curve is x square. The curve represented by the red line, and the curve represented by the blue line is my y equal to x curve. If I just wanted to plot a curve with x cube also, so what I am going to do, just going to write plt dot plot a comma b raised to power 3. So it is going to show me 3 curves. This one is my x cube curve. Let me just take the pen. This is my x cube curve. Sorry, y cube. Sorry, y cube. This is my y cube curve. This is my y square curve. And this is my x equal to y curve. This is my simple y. Cool. I think the if the plot is clear, just you can write plot in the chat section so that I can proceed. You can also use the upper function that we discussed. You can use x label, y label. So use grid. For example, you can use plt dot grid. So it will just give you a grid. Cool. I think these things are clear to you. So next on, we should move on to plotting more good things. For example, we can. So nextly, we are going to plot histogram. Histogram and bar graphs we are going to see. Histogram. Cool. So for plotting histogram, I would require the random variables values to be in categories for plotting the histogram. Cool. So let me take 2 numbers which have category. Let me just plot a simple histogram. For example, I am having A. To take the category value, I'm just going to call a function called random int that we have studied. np dot random dot random int. So what I'm going is I need value from 0 to 10 and I need 7 values. Cool. I also can print A. So I'm getting values in categories, or I can just type here 20 values so that it can be all clear. So I am getting repeated values. We can only plot histogram and bar graph for repeated values also. Otherwise, it will be distinct for each and every value. So what I'm going to do is I'm for plotting bar. We just have a simple function. We have a simple function. Also, let me take indices. Here, indices is let me take b equal to np dot array uh, list of range of len of a. Uh, I think you are getting. Let me just draw it and then explain it to you. So what I'm having is plt dot bar. First, I will pass b the indices, and then I'm going to pass a, and I will write plt dot show. See, I'm getting bar graphs. As I'm having my range from 0 to 20, I'm having frequency of 20 numbers. So I have taken my indices to be 20. Guys, are you getting it? If bar you are getting till now, just write bar. Otherwise, I can explain. With the help of A, I'm just creating multiple values. For example, here it is occurring 5 multiple times. And with the help of V, I'm just checking the variation to which it is belonging. For example, we are having total number of 20 values. So my graph should contain 20 lengths. For example, 0 to 20. Let me take a pen. For example, here I am getting 20 values, and I am also creating an index so that I can plot all the values. So my index should be from 0 to 20. You getting it, guys? So that's why I created an array of 0 to 20. Cool. Those who are, if it is clear, I can also plot multiple graphs in same. For example, if I type c equal to np dot random, as it is going to give me random values, so obviously c will contain different values from a. If I do this, and I can plot another plt dot bar, and I'm just going to plot c comma b comma c, sorry, b comma c, first index and then values. So what I'm getting is I'm getting a overlap values. Guys, what we are getting overlapped values. If I want these values to be different, so we can just check the plt dot bar arguments. There are many arguments over there, and we can just play with them. So it is having an argument of height, alignment, center, with it is having an argument called uh, okay. We are going to see that afterwards. First, let me tell you how to shift my graph. Wait a sec. If I just want my one graph to be shifted a little bit right, what I'm going to do is I'm just going to add uh, I'm go I'm just going to change the indices of bar B. So I'm going to just add 0.25 to it. 0.25 index. Oh, I removed a comma. Sorry, my mistake. Now you see that my graph has been shifted a lot. Shifted. If I would have lesser values, for example, 10, see. So my one graph has been shifted and now it's not overlapping. So we can shift our graph with this by adding the values in our index, and also we can do do more things, like we can shift We can also specify labels and all these things. Uh, See, what I've done is I have just shifted my graph B over 0.25. Now they are not becoming overlap. Are you getting it? First I shifted the index, then I shifted how my graphs are plotted. Cool guys. So you can just play with all these things.
Guys, you have to explore these things. Okay, you
Yeah.
understand? Then you can able to learn these things.
Yeah, cool. We have created bar graph now. So next, let's move on to pie charts, and then we are going to see histogram. Okay, cool. So creating a pie chart is quite easy. For example, let me mark it down. Pie chart. So I will pie. So I'm having a list of A, which is having A, comma B, comma comma C, comma D. I'm having a list which is having values, for example, 10, 100, 70, and 25. Cool. I'm having two lists. So for drawing pie charts, I just need to write plt.py. And in this pie chart, I'm just going to pass both the arguments. First, I'm going to pass values and then I'm going to pass labels. To specify it, these are called my values and these are my labels. So I will pass values. Then I'm going to pass labels. PLT values is not defined. Let me run it. Cool. Uh, Values I've run. Oh, sorry. PLT dot show. What it is showing. Just wait a sec. Let me change it to label. And now I'm just because it is having a argument values.
Integer में convert कर देते. Value integers.
Values already in int. Just give me a sec. I'm having values and labels as L. Wait a sec. Because there is an argument, I think that might be labels equal to label. Cool. So I'm getting a graph. First I'm passing is values and my next argument is label. So in that I'm passing label. So this blue portion consists of A, red portion consists of D, and this green portion consists of C, and this orange portion consists of B because B has the maximum value 100. So guys, are you getting? We can also do quite a bit more things on it. We can also bust few of the portions out. To bust portions out, we just need to provide explode equal to. So we need my first label to remain same. So I will just write 0. Second to remain same, and I need my third label to explode out. Just wait a second. My oh shit, yaar. My third label to explode out. So in explode, I'm just providing values. So what it is saying, it is exploding out the third part. Are you getting?
So can you please explain explode part?
Yeah, sure. I'm just saying I'm passing a list to explode, and I'm defining which portion to come out of my pie chart. So here I'm doing, where is my pencil? So when I'm providing it 0.1, so what it is doing is it is bringing A out of the chart. Are you seeing? And
Yes, sir.
I want C to be exploded out more. So it is bringing out C more of the pie chart. Are you seeing it?
Yeah, yeah. Okay, sir. Clear.
Now we are going to see histogram. Histogram, for seeing histogram. Let me just mark it down. Histogram. Cool. For making histogram, we need a few of the values. And we need more of the things. I will explain you how my histogram works. Uh, for that, I just need to write few of the things, and then I will explain you why I am writing those. Cool. Uh, and I'm just first I will plot the histogram. Then I am going to tell you everything about that. Cool. Let it be 0.4, and then what I'm getting is I will I will get uh, values equal to u plus s into np dot arrange. Cool. Np dot arrange, and how many values I should need. Let me take values, or no, I should take random values so that they should be in categories. Np dot random dot random int. I need few of the random values, so I am just calling random int. We can also explore more of the random functions that you want. We can explore random rand, and we can explore all functions. For example, if I just write rand n, it is also going to provide me the same values, rand n, and if I type 200, it is also going to provide me 200 random values. Cool. This thing I am going to explain you. First, let me draw the histogram. Plt dot, for drawing histogram, we have a function called hist. And in this function, I'm just going to pass my values. Well, what is this happening? I'm just going to pass well, and then I'm just going to plot. See. Cool. Let me just take a marker and explain you out. Actually, the U is my mean. It is mu, that is mean, and S is my standard deviation, STD. And what I'm doing is I'm generating a value. I'm generating 200 value between the first of all, let me just draw something also here. If you can just relate, is this function similar to what we have studied, what I have told you earlier? I think it is similar. So I just wanted to plot a such function. So what I did is I took the mean as 5. You can take mean any value you want, and I took standard deviation as 0.4. So and I generated 200 values, random values. I multiplied it by standard deviation and added a mu to it. To make it more clear, let me just give you tell you what rand n is giving me. Np dot random dot rand n, and if I pass 200, see guys, I will get value from -1 to 1. I will only get value from -1 to 1. Now if I'm getting values from -1 to 1, I'm having values from -1 to 1. Rand n is only giving me values from -1 to 1. So what I'm doing is I'm multiplying each of the value by 0.4. So my values are being to it is becoming minus 0.4 to plus 0.4. And then I am adding my mean to it. So what it is doing, it is giving values from, if I will add 5 to it, it will just give me 4.6. And here I will get 5.4. So I'm getting my values in this range only. And just I'm plotting them. So you can see that values I'm getting from here to here. Is it clear? If you want me to repeat, I can repeat, because this is the last topic and we are having still. Okay, I got it. Let me just clear all. So my equation is mean plus standard deviation multiply a NumPy array, NP array. Cool. NP array. Now we have seen if we multiply this with NP array, all the values get multiplied. So initially it was returning me values between the range -1 to 1. Then what I'm doing is I'm just multiplying the values with my standard deviation, that is 0.4, and the values are becoming in the range between -0.4 to 4. I'm just talking of all the values. -0.4 to 4, cool. And what I'm doing is now I'm adding mean. If I add something to my NumPy array, it gets added to whole, to each and every element. So my this value is becoming 4.6. And this value is becoming 5.4. If this thing is clear, then say clear, otherwise say repeat. And I'm getting a bunch of these values and I'm plotting them over here. Cool. Okay. So I can make it more intuitive. More intuitive. Let's make it more intuitive. For example, I just need range between 3. So what I will do is I have plotted the graph and I have got all the values. Now to make it more intuitive, I'm multiplying it by 0.4. I'm multiplying it by 0.4. You will notice that each and every element is coming out to be. There is a power, e raised to the power minus 0, 1 means 10 raised to the power minus 1. E means 10. So my whole the elements are skewed between the range -0.4 to 0.4. And if I'm just going to add my mean 10, for example, my mean is 10. So the value will become from 9.6 to 10.4. See, all the value will be from 9.6 to 10.4, and the value will be in category. So all the changes will be reflected here. For example, let me take mean as 10. See my graph is coming out to be same. Are you getting it? Cool. This was the file that we were working on. Let me just run all the cells. Run all. Everything is done. Okay, cool. Now we haven't imported Matplotlib. Import Matplotlib dot pyplot as plt import cbot sns. So these two libraries are used to plot data. This second library is Seaborn. So Seaborn is not there in our course, but I need you to just know about it. So we can just plot graphs with the help of Seaborn libraries. For example, if you want uh, and you will get to know how this Seaborn is quite useful in plotting the data graph. When we are just going to see in our next class, when we are going to check out all the, we are going to visualize all the columns in our data set. From the next class, we are going to visualize all the columns in our data set. Then you will see how important Seaborn is. You can just plot each and everything, uh, uh, each and everything, each and everything so seamlessly that you won't. So let me just show you how. So cns dot plot. If I just wanted to plot the data frame, let me check. Data frame I cannot plot. See, okay. So if I just wanted to plot any column of the data frame, for example, I have a column, let's say integer type column, integer type column, float, it is float. If I just wanted to plot the budget, what I need to do is I just need to type budget here, and it is going to plot that for me. Wait a sec, I'm just making few mistakes. Let me just clear it out.
हाँ प्लॉट नहीं होता फीचर, कोई और होता फीचर.
Plot नहीं होता.
कोई और फीचर होता. टैब डाल के देख, टैब डाल, टैब.
Sorry. Yeah, I got it. Actually, Seaborn has few other features. For example, it has this type of features.
बार प्लॉट कर लेंगे यार कुछ.
So we let's see which is plot pair plot. Oh, sorry, I actually didn't visualize it. It's pair plot. What my pair plot is going to do, it is going to plot all the things which are there in my data frame. Now you will see something amazing. Actually, it takes some time to plot, but you are going to see things quite good, quite intuitive. Actually, it is taking time. What it is going to do is it is going to plot my every column against every other column. It is going to plot my every column against every other column. So it is quite intuitive. It's taking time because we have such large number of columns. See, See, now let's see what this is. This is cool. I think this is cool. So what it has done is it has plotted my column with against every other column so that I can visualize how my things are varying with that column. For example, let's see. When we are going to study ahead, we can see that here it is a function like this. Sorry for the wrong drawing. Let me just remove it. Sorry for the wrong drawing. So here it is just like this. So like this, and you can also see few of the linear functions like this is a linear function. You can also see inverse functions here if they are changing inversely with each other. For example, if I check this here is the name of the column. It is plotted against the column name down here. So it is varying linear with it, and we can check few of the like this is quite good. If I just wanted to visualize one column value with another column value, I can just use Seaborn to plot. Otherwise, what I would have done, I would have called Matplotlib to plot again and again. That would have been a hectic task. So you can visualize functions here. For example, if we have less number of rows, so let's do that also. For example, if I draw few of the rows, then the things will become more clear to you. Uh, Instead of running this again, let me just create a code section here and df dot columns. So it is columns. Sorry for the typo. So I am having such column. Let's drop few of them. Let's delete few of them from our data set and see how things are going on. So for dropping from we just need to type df dot drop. Then we have to type the column names df of. We are going to drop all these columns, and here is a in place. This we are going to see tomorrow. What I've done earlier is it's in place. Invalid syntax. Why it is showing invalid syntax? I must have inserted one more. Cool. Wait a minute, let me check. Oh, I have not provided the access. Sorry. Still not. Where is the likes? Likes. Where is likes?
वो टू डायरेक्टर से पहले वो एक्सक्लेमेटरी मार्क मार.
Yeah. I've just written there also. I think I copied the.
वो in place is equal to true होगा.
हाँ, वो in place is equal to true होगा, but I have copied wrong things. Let me correct it out. This is cool. This is cool. This is cool. This is cool. I think this is cool. Just let me figure it out. What is the mistake? Let me just copy out all the columns.
but
Let me just copy out.
सिर्फ ऐसा करियो डीएफ हटा.
Yeah,
डीएफ हटा, सर df डॉट ड्रॉप करना और कॉलम का नाम डाल सर
dot drop
वो ब्रैकेट करके उसमें कॉलम का नाम डाल
लिस्ट लिख दे पूरी लिस्ट हाँ
हाँ कलर करेंगे हाँ बस इतना डाल
in place is equal to true
in place equal to true, and I have to provide access equal to 1. This we are going to explore more about it on our next class. I'm saying it will be
in place हटा
in place will
df
it is in place not in place in in
In place.
हाँ
In place. Yeah.
okay in place.
और df हटा
So guys, we are going to see that in detail. Okay, cool. The columns have been dropped. So if I will look at the df dot header, I will get less columns. So that I can explain it to you. But cool. We are having less columns. Less columns. So we can just write df dot shape, shape, df dot shape, df. Okay, shape. So what it we are having 18 columns still. So let me just drop few of more columns so that this thing can become clear to you. If we have less number of columns, then I would be able to explain you well how what things are going on. Cool. We have dropped more number of column. Let's see how columns 12. Cool. So we have 12 columns. Now let's print our graph and let me explain you how things are going on. Cool. Now the graph looks much bigger and better. So let me just take out my pen, and I can recognize, for example, this graph is following the trajectory like this. Cool. I can just draw out few of the conclusions. For example, the max value in this graph is this. All the elements are below this. And I can draw it out for 2. For example, this graph is between this column, the values of this column, and let me go. Okay, I need to clear the screen. And, for example, this graph, the last graph, it is between this column. Where is my pen? For example, last graph, this graph is between this column and this column. Number of voted users between number user per for review. So how my users are voting now. So you can just get the idea of how the graph is. For example, this graph is following certain trajectory like this. And you can just get a clean idea of the graph. So we will use quite a lot of Seaborn also, if you will say. Otherwise, we are going to use Matplotlib to visualize our data.